All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answer. So for the factoring, you should have x plus 9 times x minus 2. For the math knowledge question, we have a person that walks south 4 and then turns 90 degrees and walks east an equal distance. So 4 and 4. If we went in a straight line, how far are they from their original starting point? So what is our hypotenuse? This is a right triangle, so we can use Pythagorean theorem. 4 squared plus 4 squared equals c squared. So 16 plus 16 equals c squared. So 32 equals c squared. And then if you take the square root of that, the square root of 32 reduces. And so I'm going to go over how to reduce radicals. If you've had me before, then you'll know how to do that. Otherwise, you may not. So this is what I do. I factor it, make a factor tree. So 32 I know is 4 times 8. You can factor it however you want. 4 is 2 times 2. 8 is 2 times 4. And then 4 is again 2 times 2. So 16 is 1, 2, 3, 4, 5. 32 is 5 2's. So we have 2 times 2 times 2 times 2 times 2. So that makes 32. We're dealing with square roots. So to take anything out of a square root, you have to have 2 of them. You have to have a pair. So this is one pair, and I can pull it out and put it on the outside. And this is another pair, and I can pull it out and put it on the outside. So we have 2 times 2 on the outside, which is 4, and then there is one little 2 left on the inside. So your answer would be 4 square roots of 2. So if that's not how you learned how to simplify radicals, and you're able to do it another way, that is perfectly fine. However you want to simplify them is fine with me. But that's what I do just because I think it's the easiest, most straightforward way to always get them correct. It may not be the fastest, but if you can factor it, then you should be able to get them correct. So we're looking at lesson 20 today. We're going to be interpreting truth tables. So hopefully after this lesson, you will be able to interpret truth tables. So before we get there, we're going to start with a biconditional statement. So a biconditional statement is where you combine a conditional statement and the converse. The biconditional statement is true only when both the original and the converse are true. And the biconditional of if P then Q and if Q then P is written as P if and only if Q. So you take your hypothesis and conclusion and put them together and say hypothesis if and only if conclusion. So let's look here. We want to state the converse. The converse, if an animal is a bird, then it has 2 legs. The converse is going to be if an animal has 2 legs, then it is a bird. We want to determine if the statement and the converse are true. So if an animal is a bird, it has 2 legs. This is a true statement. But if an animal has 2 legs, then it is a bird. That is false. Can you think of an example of an animal that has 2 legs that is not a bird? Hopefully, maybe you're thinking of a human. We are animals, or mammals, and we have 2 legs, but we are not birds. So it says, determine the statement and the converse are true. The statement is true, the converse is false. So now it says write the biconditional. So the biconditional is going to be an animal is a bird if and only if can be written as IFF. So if and only if goes to IFF. That is a mathematical shorthand. So an animal is a bird if and only if it has two legs. Now, the biconditional is only true if both the original and the converse were true. Since they were not both true, the biconditional is false. Okay, so that's that first example. Now we're going to look at truth tables. A truth table is a table that lists all possible combinations of truth values for a hypothesis and conclusion, and then the conditional statement or whatever statement they're asking you to form. So truth tables are useful because they show all of your possibilities at a simple glance. And this is what a truth table looks like. You have your hypothesis and your conclusion. You can either have a true true or a true false, a false true, and a false false for your hypothesis and conclusion. This is the conditional statement, if P then Q. If you start with a true statement and you conclude something false, then your statement is true. However, if you start with something true and you conclude something false, you have a false conditional statement. Now, if you start with something false, it does not matter if you end with a true or false conclusion. The statement is true. So it doesn't matter if your hypothesis is false. It doesn't matter what your conclusion is. If you start with something false, then it's a true statement. Doesn't mean that it makes sense, but it is true. So let's look here. If a polygon is a quadrilateral, then the figure has 4 sides. So we're going to use a truth table to represent this statement, and then we're going to add for the converse and the biconditional. So you're going to need to have 5 columns in total. You're also going to have 5 rows. The first one is going to be for your hypothesis, which is your P. Your second one is going to be for your conclusion, which is your Q. And we're going to start with those to start with. So you always want to make it true, true, false, false, and then true, false, true, false. Those are always going to be the same. That part should always look exactly the same. And then it says to do the statement. So the statement is if P, then Q, or P implies Q. That's another way you can write it. So true, true means the statement would be true. True to false means it would be false. And then if we start with a false hypothesis, the conclusion is going to be true. So that would be part A. Now we're going to add for the converse. So the converse is if Q, then P, or Q implies P. So we have to go backwards. So we start with Q and we go true, true. Well, that's a true statement. And now we do false, true. Well, we started with a false statement, so it has to be a true statement. Doesn't matter what the conclusion is. And then we started with a true hypothesis and ended with a false conclusion. So that is false. And then false, false is a true converse. So that's your converse. And then your biconditional is P, if and only if Q. So it is only true when both the original and the converse are true. So it would be a true biconditional here, a false one here, and a true biconditional there. So that would be how you make a truth table. Okay, we're going to look at compound statements now. A compound statement combines 2 statements using either and or. It's similar to a conditional statement that instead of having if and then, you have an and an or. So P and Q, or you would have P or Q. if you have it P and Q, that's called a conjunction. And if you have P or Q, that's called a disjunction. Okay? So we're going to look at this example. At the theater, you can buy popcorn. You can also buy a drink. What is the conjunction of these statements? At the theater, you can buy popcorn and a drink. We're going to do the truth value in just a second. What is the disjunction of these statements? At the theater, you can buy popcorn or a drink. Okay, and so now we are going to make our truth table. And so again, you need to have 5 rows, and we're going to need 4 columns on this one. All right, so for this one, this is going to be your hypothesis. And this is going to be your conclusion. And they should always look the same. T, T, F, F, and then T, F, T, F. Now for the conjunction, that's P and Q. That's only going to be true when both of them are true. So both of them are true here, but none of the other ones have where they are both true. So for the conjunction, it's only going to be true when both you can buy a popcorn and a drink are true. So this one is true because it says you can buy popcorn and you can buy a drink. Okay, now the disjunction would be P or Q. So that's true when one of them is true. So this first one, both of them are true. One of them is true here, one of them is true here, but here one of them is not true. So for this disjunction, it is true because we have to have at least one of them true. And actually they both happen to be true. But this disjunction is true because at least one of them is true. Okay, so now we're going to look at example 4. When stars run out of fuel, they either become black holes or degenerate stars. Consider the statement. A star will become a degenerate star, and a star will become a black hole. The conjunction would be a star will become a degenerate star and a black hole. And the disjunction would be a star will become a degenerate star or a black hole. So that's the conjunction and the disjunction. Now it wants to know, is the conjunction true? The conjunction is not true. The conjunction is false because it said at the beginning it's either going to become a black hole or a degenerate star. It can't be both. So this conjunction would be false. Is this disjunction true? Will it become either a star or a black hole? Yes. So this one will be true because eventually it'll become either a black hole or a degenerate star. So that's how you can use truth tables, conjunctions, and disjunctions. So let's see if y'all can do these practice problems by yourself and then unpause the video and I'll go over them. So the converse would be if a quadrilateral is a rhombus, then it is equiangular. Determine whether this statement is true. If a quadrilateral is equiangular, then it is a rhombus. That's not true. Is the converse true? If it is a rhombus, it is equiangular. No. Rhombuses talk about equilateral. So write the biconditional. A quadrilateral is equiangular if and only if, so IFF, it is a rhombus. Are both the original and the converse true? No. So this is false. And the reason, neither one of these were true. Both of them have to be false. Both of them have to be true. So we can't have a true biconditional statement. Looking at this one, we want to use the information to answer D through G. So we're going to go on with this information to some more problems. Y'all pause the video and try them, and then we'll go over them. So we want to use truth tables to represent the given statements. And then we're going to interpret it for the statement, and then we're going to add for the converse and the biconditional. All right, so we're going to start off with our P and Q. And they're always true, true, false, false, and true, false, true, false. Okay? And now we're going to add for the statement. So P implies Q. So that's going to be true, false, true, true. And it says interpret the truth table for the statements. So this is going to be true. It says if customers order a filet mignon, they receive leek soup. So if they order a filet, or if they do not order a filet, it can be a true statement. And then if customers order grilled salmon, they receive baby spinach. So if they order grilled salmon, if that's a true statement, then they'll receive baby spinach. So that's all you have to say there. For the converse and the biconditional. So the converse, you do Q, then P. So that's going to be true, true, false, true. And it's going to be true if they receive leek soup, then that means that they ordered filet. And if they receive baby spinach, that means they ordered salmon. And then we're going to say the biconditional. P if and only if Q. So it's true here and here. And it's false here and here. It's true only when both of them are true. So for this one, for the biconditional, it's only going to be true whenever both the original and the converse are true. And so if you order a grilled salmon entree, or if you order a filet mignon, if and only if you receive leek soup. So that would be the first part. Now we're going to look at this next one, and it wants us to only consider F, for F and G, only consider a customer orders filet and they receive a baby spinach appetizer. So what is the conjunction? The conjunction is going to be a customer orders a filet and receives a baby salad appetizer. And then the disjunction is going to change this and to an or. And it says use a truth table to assess its truth value. So we're going to come back here and we're going to add to that truth value, or the truth table. So y'all can just continue it on your page. You don't have to draw the whole thing out again. So we can do the conjunction P and Q and the disjunction P or Q. This is all we're adding to it. So it's only true when they are both true. So true and then false, false, false. So the conjunction, it says the customer orders a filet and receives a baby salad. That's not true, because if they order a filet, they receive leek soup. So this is going to be a false conjunction. But the disjunction is true when one of them is true. So true, 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 false. So do they order a filet or receive a baby salad? Yes, that is true. So the disjunction is a true statement. Okay, so hopefully that helps you a little bit with truth tables. They look a lot alike every time. So as you're doing them, hopefully you'll get better and you'll recognize the pattern on them. So let's look at this challenge question. Use a truth table to represent the following statement, then explain the table. It is a sunny day, and on sunny days it does not rain, so it is not raining. So y'all pause the video, and then I'll go over this one. So for this truth table, we're going to have our P and our Q. And then we're going to have our statement. P implies Q. So true, true, false, false. And then true, false, true, false. So this one would be true. This one is true. This one is true. And this one is true. Why are they all true? This statement is true regardless of the truth value. This is a tautology. It's a statement where when it says for P, for this to happen, then Q happens, there's only one possible answer. It's a sunny days, and on sunny days it doesn't rain, so it's not raining. If it's a sunny day, then it's not going to be raining, because it says on sunny days it does not rain. So this one is always going to be true, no matter what you have for your P and your Q. This is always going to be a true statement. So that's kind of a trick question, because it's a tautology that's always going to be a true statement. So usually they don't have it where they all end up being true. Alright, so your homework is 1 through 30, so make sure that y'all do those tonight so we can go over any questions you have tomorrow.